Hello Rafa, okay, so I have your microprocessor and the printer again on the bench. So you asked me to measure the power supplies, right? So for the printer, I'm just using a standard power supply, one of these where you can switch the voltage. So I have set this to 7.5 volts. You can also do 9 or 12. I mean, I wouldn't go much higher than say 9, so because otherwise the converters get very hot on board, right? These things here under the heat sink. So 7.5. I always try to find the lowest voltage setting with which it works, right? And of course, you're right. This is for the US grid is 110 volts and 60 hertz, right? Whereas on Tenerife it would be 220 volts and 50 hertz. The hertz shouldn't matter, right? But actually I'm not even sure if it's 50 or 60 hertz in Europe or on Tenerife. But so I plugged that in now, so if you measure that here, then center positive, right? So, and turn on the voltage meter, multimeter. Yeah, then we get, hope you can see that, 7.5 volts. So that's the one I'm using for the printer. And for the microprocessor, it's basically very much the same. Let me show you this. I think this is the original power supply that came with it in the US. And this has 9 volts DC output, right? 1 amp. Yeah, that's also kind of, and center tip polarity also positive. The amps are also important, right? You shouldn't go below 1 amp. So if your power supply has something like 250 milliamps or so, that's not enough, right? So I would get like a decent 2 amp or 2.5 amp wall wart, as we call them, these generic power supplies. So and if I measure that, then it should also still be in range. We just said 9 volts, right? Of course, the microprocessor, all of those devices run on 9 volts, right? With the exception of the printer that needs a little bit more, but you see this one actually has 12 volts on the display now, right? So it produces more than the 9 volts it declares, but once there is load on the power supply, the voltage goes down. So, okay, so those are the voltages, 7.5 and 9 volts or even 12 volts for the microprocessor. And really that doesn't matter because the microprocessor also is perfectly fine with the other power supply with 12 volts, right? So I can also switch those around actually, right? So let me use now the 7.5 volts on the microprocessor and the other one on the printer. Okay, so this is at 9 volt, 12 volt now on the printer. Always power the printer up first, right? Plug that in. And then 7.5 volts from my generic wall wart for the microprocessor. There you go. And then just print whatever is in memory by going to address 6000. And you see that works right out of the box for me. You can have this cable, by the way. I don't need that. You don't need to pay me for that. I just send it to you. It's an older cable, but it's not pretty. It's a little bit yellowed or whatever, but it's working perfectly fine. Okay, and then you asked me to write a little program, and starting at memory address 1800. I printed that out a while ago. I don't know what that is. I just found that in my microprocessor box. So let's just type that in. I think this is one of the counters or something. So let's do this. 3E. No, I already forgot how to use that thing. Data 3E, right? Yes, 00. 3C F5 21 00 19. CD 7806 F1 F5 DD 2100 19 CD 2406 F1 18 EC. Let's double check. 3E003C F5 21 19 7806 F1 F5 DD 2100 19 CD 2406 F1 18 EC. Good. Let's see what it does. Yeah, indeed, it's a counter. Just it doesn't clear the display, right? That's fine. So that's normal because in this version of the program I didn't clear the display buffer for these. So and then we want to print that address 6000, start address 1800, and there it goes. I should have specified the end address. Okay, let's see what it does, if we can understand how the counter works. So it starts by loading the accumulator with 0, then it increments the accumulator, it pushes the accumulator on the stack, because we're using now this system call at 1900. This is where the display buffer is, right? So you have to give this display call that we're using to create the bit pattern for the display from the accumulator value, right? What we see on this display. It needs a buffer, and the buffer is specified giving it the pointer to a memory location 1900 in the HL register pair, 16-bit address register. And then we are calling this firmware routine 0678, which produces a bit pattern, right? So now we have the number in the bit pattern for the display in the memory at 1900. Then we are destroyed, as we say, the register, the counter, right? So we had saved this counter in A in the accumulator on the stack, so we are getting it back from the stack by popping it. And now we need a second system call. This is why we have to push the accumulator and the F register for flags, right, on the stack again to save it. This time we have to load the IX register, the index register, with the display buffer address 1900, and then call 0624 is the firmware routine that now puts the display pattern from the buffer at 1900 onto the LED display, onto the screen, right? And after that we have to restore our accumulator because it was destroyed, and then we are jumping back to 1802. So the program actually ends with a jump here, jump relative, right? So this is the last instruction of the program. So yeah, all of this is totally fine, and again, I have no issues whatsoever with your printer. So I think it's most likely it was the cable, right? So maybe the data lines were broken, right? So that it got some of the control signals, so it was moving, right? But it didn't get the right bit patterns. So it's still mysterious. I don't know why and what exactly happened. And you can also, I mean, if you should have that issue again, check that your power supply, especially the one for the printer, provides sufficient amps, right? At least 1 and 1.5 amp. You don't need to go higher than that, but right. Let me also show that it's not that critical actually by swapping the power supplies, right? So this one is a 7.5 volts. I put that now into the printer, and it maybe prints a little bit weaker and a little bit slower, but it still works. And this is now the old power supply for the microprocessor. This gets now a little bit more voltage, so this guy gets a little bit warmer, but you know, they're supposed to get warm. And again, of course the program is gone now, but I can still invoke the printing program, right? Go. And the printer. This is interesting, very interesting. Now it actually does not print. Very good. So we reproduce the issue. Oh, very, very good. I'm glad we found that. So apparently, my power supply with 7.5 volts is now also insufficient. So remember how I said I wanted to supply as little voltage as possible? Well, 7.5 volts is not good enough, it seems, right? So see here, this is actually a 3 amp, no, half an amp, 0.5 amps. So that might actually also be a little bit too little. So put this to 9 volts now. Let's see if it makes a difference. So at that point we know it's the power supply which causes this. Very interesting. I would not have thought that. Good that I made that experiment. Alright, yes. Also not good enough. So not all power supplies work. This is very interesting. So let me get a different power supply now for this guy. So you really need a decent power supply. Hang on. Alright, so here's another one, 1.8 amps, and I set it to 7.5 volts. So I always measure them first to make sure that the polarity is correct, so it doesn't destroy anything, right? Let's measure the voltage, make sure center polarity is positive. So the red one in the middle should be plus. And it's not, so it's minus, so I have to move this one around. Right, this is also something you got to check, of course, that the polarity is correct. And what's worse is sometimes they have labels plus and minus, but they were from different power supplies, so they actually don't match, Okay, so this is 7.5 volts now. Perfect. There you go, Mr. Printer. And the microprocessor gets power 2 again. Let's see if it wants to print with this one. Yeah, so this one it likes too, right? So, okay, mystery solved. It's most likely your power supply. So I'm just going to send it back to you and you should be fine. Alright, good luck.